everyone, this is DK sir. Now today we'll go through what is logarithmic functions. So as I mentioned here, we have certain points you can see. The first it is what is logarithmic function. Then second point we'll go for how to plot the graph of logarithmic functions in different forms. Now next topic it is how to find a domain and range of logarithmic functions. The next part it is what are the properties of logarithmic function. That's very important here. After that we will solve certain questions based on properties of log. After that the last topic here that we'll discuss in this video, that is problem based on log antilog table. This is most important, mostly for physics and chemistry. There will use this thing here. Okay, so let's just start. As we discussed earlier also, log basically consists of three significant places. First one, this is called as power. Next it is called as its place value, or it is called its main value. Next is called as its base value. Now as I said earlier also, it's log, like suppose log x raised to the power b, and its base is a. So this is any standard representation of log questions. Okay, let's just proceed further. See here, if I say anywhere it is mentioned log x base a is equal to y, so there this function is actually log function, and this is their equivalent to x is equals to a raised to the power y. See, whatever it is base, that will go there. This base will become again the base of y, then y will go in the power. So always remember, this is very important property of log also, that we'll discuss later on. So as you can see, x is equals to a raised to the power y. So for the time being, just forget about log, that we don't know anything about log. We will just know only about x is equals to a raised to the power y. So it is a kind of exponential functions. In this one you can say this base a, whatever it is, for logarithmic functions, always remember a should not be equal to 1. As well as we have one more condition, a has to be greater than 0. So if you say a is not equal to 1, a is greater than 0, so what could be a? A have two possibility. A could be either greater than 1, or a could be a is less than 1 and greater than 0. So we have two possible cases for a. So suppose if I'm taking first case, where we can say a is greater than 1. So if a is greater than 1, suppose let's just take a is equals to 2. So if a is equals to 2, so the question will become x is equals to 2 raised to the power y. This is a function we have. Now if I said here, can we plot the graph of this function? Yes, let's just see, x here, y here. Now if I take y as 0, so you will get here 2 raised to the power 0, that's 1. Now if I take y as 1, you will get 2 raised to the power 1, that's 2. If I take here 2, so you'll get now 2 raised to the power 2, that's 4. If you take 3, 2 raised to the power 3, that's 8. Suppose if I take minus 1, so you'll get 2 raised to the power minus 1, that's 1 by 2. 1 by 2 means here 0.5. Now if I take minus 2, you'll get 0.25. Now we can easily plot these values. Let's just plot the graph of this. See here, roughly we can say here, as this is x-axis, this is y-axis. Now as you are taking x as 0, y as 0, you are getting x as 1. So x as 1, so you got a point, that is 1, 0. Now as you are saying, we are getting x as 2 when we have, you can see in the graph, we will get y as 1. So we have a point here 1, 2. We have a point here 2, 4. Just plot those points. So 1, 2, that's 2, 1 here. Next, if you take 2 here, so it is 2, 0. So 2, 1, it will be 1 bit above. So suppose this is a point. Then we'll get here, suppose x is, y should be 3. Then we have x as 8. So once you substitute x as 8, you'll get y as 3. So you are getting a point here. So if you just join these all points in a freehand curve, you'll get a graph like this. Now if you notice other part, if you are taking 0.5, for 0.5 what is height? Minus 1. So you'll get a point here. Then for you'll get minus 2, you're getting 0.25. So that graph, it is coming closer to the y-axis. So this part, if finalized, if you just want to plot properly, so the graph will looks like it goes from here, it crosses the axis like this. So this is the graph of log x, where its base is a, and that a is greater than 1. Always remember here, that's very important concept. Now in this case here, if I say what is domain of this function, so domain, you will say all possible values of x where the function exists. So let's just go back in the graph. If you see it here, okay, so in this case here, if you see, this is a point where it is x is equals to 0 and this is x is equals to infinity. So you can see the graph, whatever we have, that is between 0 to infinity for x value. So that is called as domain. So you will say x belongs to 0 to infinity, as well as 0 is also open interval, infinity is also open interval. Now if I say what it's a range, range means the value of y. You can see the graph goes up to below minus infinity, as well as slightly it graph goes up to infinity. So what will say y belongs to r. Got it? So this you will get domain and range of logarithmic functions. See there in this one, if I take second case, there you are saying log, suppose log x base 1 by 2 it is. That means that here, if we just talk about log x base a, so you will say a is greater than 0. So a is greater than 0 but less than 1. So that case here, if you talk about, suppose if you are taking here the function is x is equals to a raised to the power y, substitute a as 1 by 2. So you'll get x is equals to 1 by 2 raised to the power y. So now again we can take certain values for x and y. Suppose I'm taking y as 0, so you'll get 1 by 2 raised to the power 0, that's 1. If I'm taking y as 1, so you'll get 1 by raised to the power 1, that's 0.05. Then if I take 2, you will get here 0.25. Now if I take minus 1, you will get here 2. If I take minus 2, you will get 4. So that means you can notice here, this particular session says, if you just plot the graph, okay, so for y0 we have 0.1, that means it is 1 comma 0. Next it is, we have 0.5 comma 1. Next we have 0.25 comma 2. So that means here, if you notice, x is 1 and y is 0. So there we have a point here. The next will be 0.5 comma 1. So for 0.5 we are getting height as 1. Then again 0.25 we are getting height as 2. So you can notice here, as we are going closer to the 0, the graph is going up. So that means graph is coming from there to 0. After that you can see, as we are going for x as 2, then y is minus 1. So for 2 we have minus 1, then for 4 we have minus 2, so the graph is going downside. So this is the graph of log x base a, where a is greater than 0 but less than 1. So always you have to remember here, for any logarithmic functions graph, you have to firstly see its base is what? It is between 0 to 1, or it is between like greater than 1. Okay, so now this case also you can find the domain and range. As you say, domain to all possible values of x. So this graph is defined between 0 to infinity, and its range is again minus infinity to infinity, that's r. Okay, let's just proceed further. We'll talk about certain properties of logarithmic function. That's very important concept here. Okay, if you say before that, we can take few more graphs. Like if I say I want to plot the graph of log of modulus x, and see that this case no base is mentioned. So if base is not mentioned, so remember these are standard cases. You will take base as e, or you will take base as 10. And mostly for chemistry and physics, we will use, for physics and chemistry we'll use base as 10. Base e is also called as natural, so that is ln x is also called as. Okay, so if I'm taking graph of log modulus x, so see here, modulus x means you can give x as any value, because previous case it was x you cannot give negative values, but now in this case you can give x as negative values also, that will be ditto same as positive. So firstly, if I am going to plot the graph of positive, this is a graph of log x positive. Now you will say when x will be negative, it will be ditto same as whatever you are getting positive side, same will become negative side. So it will go like this. So this case, if I say log of modulus x, it's a domain. Domain will be r. You can give any values, but you cannot give 0 because this is not continuous function for 0. So it's r minus 0. Okay. Now what's the range? Range is again same. Goes from where to where, y values. So it is any real number. Got it? Okay. Let's just proceed further. Now let's just take one more example here. If I say I want to plot the graph of modulus of log x, what will be its graph? So modulus of log x here, as you can notice, you can give x as any positive values only because you cannot give negative. X is inside of log, so you can give only positive values. So this has to be logically graph of log x. Got it? But if you say you are putting modulus of this thing, that means whatever is negative part, that negative should not come in output. That's why the new graph, it will become, it was crossing the x-axis, it will be as it is. Only whatever part was downside, it will go upside, it will come like this. So this is the graph of log x, its modulus. Okay, so you can easily find its a domain and range also there. Its a domain will be what? Obviously it is 0 to infinity. From the graph you can see it is only the right side of x-axis, and its a range you can find out here, it is only above x-axis. So that means its range will be also 0 to infinity. 0 will be open or close, it will be closed bracket. Why? Because 0 is included here. Got it here? Let's just proceed further. Now we'll go for the properties of logarithmic functions. Now in properties of logarithmic functions here, always remember this is very important topic because log is purely based on its properties, whatever type of section it is, for physics, maths or chemistry, anything. So the first property I'll discuss here, that is log a raised to the power b is what? If nothing is mentioned, it's a base. So understood, you can take 10, you can take e, it doesn't matter, don't worry about this. So this is a property, it is called as b log a. Whatever it is power, it will go front here. That's very important property, remember. Now the second property is log a into b. That can be written as log a plus log b. Third property here, log of a divided by b. That is log of a minus log of b. The fourth property here, that's very important property, it's called as also base change property, log a to the base b. It is written as log a divided by log b. See there, this base change is important because of, that's why you are saying sometime log 10 is 1. Why you are saying? Because that time you are considering its base is 10, so it can be written as log 10 divided by log 10, that's cancel out, you will get 1. Similarly, sometime you can say log e is also 1. So there you will consider base as e. So it will become log e by log e, that's again 1. Now the fifth property here, that is itself from here the derivation of log comes, that is log x base a is equals to y. So x is equals to a raised to the power y. Got it? Next property here, that's also very important properties, that is, if I say anywhere it is mentioned log x, and this is in the power of e, so it is nothing base mentioned here in this case, so you will take base as e. So you will say this is equals to just x, this log and e get cancelled. This is important for mostly integration as well as differentiation of different functions. Okay, so remember these all properties here, it's very important. Let's just take one example based on these properties. If I take a question like log x base a divided by log x base ab, it will be what? So you can easily write down this as log x divided by log a by base change property, it will be log x again divided by log of ab. So log x get cancelled, you will get this as log of ab divided by log of a. So you can write down this as again property of log a into b. So you can write down log of a plus log of b divided by log of a. Now this you can divide it individually, you will get 1 plus log b by log a. So you can write down 1 plus log b base a. This is final answer. And one more thing here, very important thing, remember this, make a note properly that log of a plus b, log of a minus b, and log of a into log of b, these three we don't have any property. Mostly students I had seen, they will do mistake, they will take log outside, so you'll get log of a plus b and they will use the wrong formula. We don't have any property, remember this dear. That's why I'll just make a notation so that you just remember this. See, I'm very bad in drawing, so that's you can understand. Okay, so always remember here, these three properties does not exist in logarithmic functions. Okay, let's just proceed further. Now we take next part, that is we will solve the problems based on antilog tables. Let's just take a question. This is mostly important for your physics and chemistry purpose. Let's just say if you have any question, x is equals to under root of 23 to make it 234. Okay, fine. Like 234.531 divided by cube root of 2345. What should be value of x? So simply here you cannot divide it because it is square root as well as cube root. So what you will do? You will say again taking log on both the side. So you will say log x is equals to log of this whole question. That means it will become under root of 234.531 divided by cube root of 2345. Now here we will use the property here log of a by b. Log of a by b is what? Log a minus log b. So it become log of under root 234.531 minus log of cube root 2345. So you can again see here this square root means power 1 by 2. So that means you can write down log of 234.531 raised to the power 1 by 2 minus log of 2345 raised to the power 1 by 3. So it will become 1 by 2 log 234.531. You can round up this, it doesn't matter, up to 5 only, minus 1 by 3 log of 2345, and this is a value of log x. Now after this dear, you have to definitely go through my first video of log as well as second video of log, and for this particular thing you just go for the first video of log. There we are using how to find the log table. So if you just check out that, you will get log 234.5 value over there. That value is how much? That you can check it. Please just go through it and check it. 2.3701 minus 1 by 3. This value also I discussed in my previous video of log. Please just go and check it once again. So that is 3.3701. Now once you got these values, so you can easily divide it. So you'll get log x is equals to 1 by 2 divided here. So once you divide by 1 by 2, you'll get 1.1850. So just ignore it, up to 4 places fine. Minus, you'll divide this part also, so you will get 1.1234. This much is enough, fine. Now you can easily simplify this. Just subtract this 2, you'll get 0.0616. That is log x. Now once you got log x is equals to this, we have to find out x, because the original question was there. If you just see, the question was what is the value of x when you divide this by this. So we just took log. Now we'll do what? Anti-log. As I said earlier also, taking anti-log on both the side. So it will become anti-log of log x is equals to anti-log of 0.0616. So anti-log and log get cancelled, you'll get just x is equals to. Now for this dear, please refer my second video of log. There I have mentioned how to use anti-log tables that I properly specified. So just go through it, and there you'll get, because of it is just one place only before decimal, so it's like nothing, 0. So that plus 1, 0 plus 1 will be 10 raised to 1, and just see 0, 6 in your main table, then 1 as a difference table, 6 as mean difference table, so you'll get 0.1153. So just multiply this, you'll get 1.153. That's final answer here. And if you want to go through it, just do one thing, just in your calculator or mobile, just check it under root of 234. So this was the question. There you can easily divide the first part in calculator, second part also in cube root, so you will get the final answer as this only. You can check it. Okay dear, please go through the video properly, and hope you like this video. If it is interesting, please just let me know dear, and I'll keep on uploading more videos. Okay, thank you dear, thank you once again.